and share my screen. And again, I'm recycling things from the last class in terms of the starting of the notes.
Oh, can I write those down? I missed those last class.
Sure. You
Thank you.
realize that they're always in Blackboard. Did you know there's a folder in Blackboard where I store all this stuff for you, so you can always get a hold of it?
The notes, the actual notes?
Yeah.
Oh, I thought I had to go and like look at the YouTube greeting, recording.
If you go into Blackboard, if you go into content, if you go into notes, let's go into Unit 4 where we are. For each day, there's two things.
Oh,
One
the
is the
YouTube.
YouTube, and the other is what we wrote.
Oh, perfect.
So that it's always fed in there.
Oh, okay,
There's
perfect.
been 2 uploads for every class. So, yeah, but you can, this is going to be for a little while. Although I have to cheat because I'm recycling this. The topic for the date has changed, and the topic for the date is going to be more annuities.
Okay.
And then we're all going to go and look at fixed payment loans.
Okay. I wanted to mention yesterday when I was doing homework, I did notice what Chris was talking about the other day, the
8.7.
the homework 27 or something.
Yeah.
I did notice that as well. And I noticed it because it was out of chronological date order. And I was like, wait a minute, why is this due on the 3rd and this is due on the 10th?
In last class, it might have been before you came in, the class as a group agreed that they wanted me to leave that in there. It's not required. It'll be extra credit. Just one extra assignment in there if anybody wants to do it. If you do it, if it's not a good grade, it will be dropped. If you don't do it, don't worry about it. It'll be dropped.
Okay.
So the interest quiz is due today. It's in My Labs. Make sure you put your work in the drop box that's in Blackboard. Exam 4 will be due on the 13th. We should finish the new content, almost all of it today. The final is on the 17th. It'll be open from 8 in the morning to 8 in the evening. Homework 20 is on percent is due today. 22 simple interest is due the 8th. 20, we've gone through 23 and 24. Today we'll start looking at 25 and 26. Everything in My Math Lab, the last day that you can work on the homework is set for the 11th. Also, project 4 will be available. This stylus does not want to work for me today. Give me a second. I got to pull the battery out and put it back in. It's a brand new battery. I just replaced it. I'm going to have it all ready and available next class, which will be the 8th. And so it'll be due, I'll give you a week for it, the 15th. It's not going to be too much more work than just one of the mortgage homework problems, so it shouldn't take too long to do unless you get overly involved with the process of picking out your house. I know that's something that I would get carried away with because, yeah. But anyway, okay. I'm hearing a little bit of an echo, so somebody I think isn't muted. But does anybody have questions about any of those? Or before we begin, does anybody want to look at anything from any of the homework assignments? Hearing nothing, I'm gonna go on the assumption that the homework's all right. Going back here, please, 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 work on these ASAP because you wanna go through them before the test. By today, we should be able to dabble in at least all of them. I think we should finish the last of the new content today. All right, then let me move class. And last class, we ended up beginning to discuss annuities, and we had said that an annuity was an account where you make regular fixed payments every compound period, and it's for savings. And so we had said that in this, A is the future value, P is the amount of each fixed payment, R is the rate expressed as a decimal, T is the time in year, and N is the number of compounds in 1 year. We said there were two different formulas to use. One is if you know what your payments are and you want to find the future value. And the other is if you know how much money you want in the future and you're trying to figure out how much money to set aside. Last class, we looked at one example because previously we had looked at an example with just compound interest saying, well, what if I want $500,000 in 30 years? If I can receive 4% compounded monthly, we looked last week and said that that meant that we would need $150,000 now to invest to get there. And so last class we said, well, what if I don't have that money and I start setting aside money on a monthly basis? And we said that using that information, the $500,000, the 4% interest for 30 years monthly, it would be round. And again, I think we also said, if you solve for P, you always round up. I know in my labs with these questions, the wording specifically says round up. Pay attention to that because it would be horrible if you did all this work, did everything right, and got it wrong because you were a penny off because you rounded the wrong way. So when you're solving for P, you always round up. Anything else, round according to their directions. So we ended up saying that it would be $121 a month. And then in the middle of this problem, we ran out of time. And that's why I recycled it from last class. And so let's pick up from where we left off, unless somebody has a question on something up to this point. Not hearing any.
So you always round up for P in annuity, right?
In an annuity and also in a compound, if you know what you want in the future and you're looking for what you need to do now, you're always going to round up because if you ever round down, you won't have enough money in the future.
Okay.
Okay. We had said that also with the future value formula for simple interest. So we're paying $721 a month, and we're going to have $500,000, $500,000 in 30 years. But when we look at that $500,000, we might want to know how much we contributed. And so that's the total of our payments. And the total of the payments will always be the payment times the number of times we do it in a year times the number of years. But the way in which we do this, we've already got that NT figure. So we're going to just write that as PNT. So here, the total of our payments is we're paying $721. And then NT, we said was 360. We're making 360 payments, 12 times a year for 30 years. And so I'm going to grab my handy dandy calculating machine and take 360 times 721 and get that I am paying out $259,560. So of that money we're getting in the end, a little bit more than half of it is money that we paid in, and the rest of it is interest, money that the bank or whatever institution we're using is giving us. And so we talk about the total interest, which is the money that you get from the bank, and that's going to be the difference between the future value and the total of the payments. And so that'll be, if you want a formula, A minus PNT, or the future value, our $500,000 minus what we put in, which is the $259,560. And so of the money that we get in the end, $240,440 is interest earned, money that they gave us for putting our money in, our payments into their institution. If you compare this interest to the question that we had done previously, that was not an annuity, but just a compound interest question, you'll see it's a little bit less. And the reason the interest is lower this way is because when we had that, I think it was right around $150,000 that we put in at the beginning of the 30 years to get the $500,000 out at the end. When we put that money in at the beginning of the 30 years, interest was earned on all of that money for all 30, every day of the 30 years. This time, the only thing that's earning interest for the full 30 years is our first payment. And every successive payment is receiving a little bit less because every successive payment isn't in there as long. And so that's why we're contributing a little bit more money this way, and we're earning a little bit less interest this way. But for most people, it's a matter of practicality. Most people don't have that extra $150,000 hanging around and can't get it. And it's easier to put in those payments regularly. So that's the annuity formula if we know what we want in the future and we want to figure out what our payments are. Let's look at an annuity question that works in the other direction. And this one, let's have you guys make it up. Let's say we will make payments of, and you know what, I'm going to add in here an adjective, monthly payments. How much money do you folks for this problem want to say we're going to set aside every month?
$100.
$100. For how many years do you guys want to do this for?
20.
20 years into an annuity that pays how about 2.5% interest, compounded monthly. What's the future value? So again, we want to figure out at the end of these 20 years, how much our $100 a month is worth. So this time we know that we're putting in $100 a month. We know that our interest rate is 2.5%. Everybody I'll write as a decimal, that would be 0.025. You've got to be careful and make sure you change that percent into a decimal. We're doing it monthly, so N is 12. We're doing it for 20 years. So NT 12 times 20, we're making 240 payments altogether. Now, we're going to use that formula since we know P and we're looking for A. We're going to use the annuity formula. We're looking for A. A equals, and it's P times parentheses, 1 plus R over N, close parentheses to the NT minus 1, close parentheses over, open parentheses, R over N. Before we go through and use this problem as I'm writing it, formula, pardon me, as I'm writing it out, again, I have to put that formula sheet into Blackboard for you. I apologize.
That formula looks so daunting. And I look at that and I just mentally check out.
Don't. It's not bad, really.
Yeah, it is. Just saying, just for me, I look at that and I'm just like, yeah, I don't know what to do.
Well, we'll show you. Before we do that, if you look at this formula, Blitzer, the textbook in my labs don't always put their parentheses around there. But if you don't use their parentheses, you're not going to get the right answer. So on the formula sheet that I give you, I promise that parentheses will be there. So we picked out the formula, we copied it correctly, we identified all our variables. So let's substitute. For P, we'll put in 100. Then we need 2 parentheses, 1 plus. For R, we're putting in 0.025. For N, we're putting in 12. We figured N times T is 240. Then we have to subtract 1 and close our parentheses. And put it over. R again is 0.025. N again is 12. And now, it's just a matter of taking your handy dandy calculating machine and typing it in. I'm going to type 100 times, then I'm going to open parentheses twice, 1 plus 0.025 divided by 12. And when I hit the 0.025 divided by 12, in my calculator display, they show that division as a slash. So it actually looks like that fraction. Now I'm going to raise it to the 240th power. Again, with my calculator, to raise it to a power, I use that caret up 240, subtract 1, close parentheses. And if I were to scroll through what I typed in, it looks very much the same as this numerator. Now I'm going to hit divided by again for that other slash that would be the bar of this fraction. Then I'm going to open parentheses, 0.025 divided by 12, close parentheses. And once I have it typed in, I'm going to hit enter. And that tells me that at the end of this time, I will have $31,097.47.
Okay. I think I got lost in the calculations on the calculator. So
What you're typing in is 100.
100.
Then you're pressing the parentheses button twice.
Wait a minute. You cut out when you said 100 and then
Times.
times. Okay.
Then you're pressing the parentheses button twice.
twice, okay.
Then you're going to type in 1.025
Yep, 1 plus,
okay, divided by
0.025
12.
divide 12, okay.
Then you're going to close parentheses once,
Once, okay, and then I got
You're
like
gonna-
a decimal, okay.
raised to the 240th power,
Shift, okay.
minus 1.
Do I do 240?
Yep.
Okay, 240 minus 1,
Then you're going to close your parentheses,
close my parentheses, okay.
and then you're going to divide it by,
Divided by,
you're going to open a parentheses,
open the parentheses, okay.
type 0.025 divided by
0.025 divided by
12,
12,
close parentheses,
close parentheses,
and then hit equal.
equal. I did not get what you have.
I think I know why.
Okay,
When you did your first set of parentheses and the one just before 12, like the 0.25, you clicked enter before you did the exponent, and then you can't do that because it's taking the operation, like it wants to raise it with the operation. You can't hit enter and then do it, or else you're going to get a ginormous number.
okay.
Is that what you did? Is there like a whatever?
I might have. I did have a really long number.
Well, you said I got a decimal.
I did. Yes,
So
I did.
I don't know if necessarily you were supposed to get the. I don't know. I'll just let the professor talk. But
No, you're right, because I have 11,472,000.
Gina,
Yeah.
with your calculator, do you have 2 lines of display? Can
I
you
do
see
not.
what you typed? Okay, then with your calculator, you might have to enter it in a different order.
Oh, that makes sense.
And so can I work with you after class to talk you through the order that you'll need to do it with your calculator?
Yes, I can give you a couple minutes. I have to be to work at 9:30, so.
Okay, well, let's bring it real quick first then.
Okay,
I think you're gonna have to go, start, 1 plus, parentheses, 1 plus 0.025 divided by 12. Close parentheses,
okay,
raise it to the 240th power.
right. Do that first application, get the answer, and then do the second one.
No, I think you should be able to do it, all at once, but I think you just need to start it inside.
Oh, okay. All right, yeah, we can do it after. That's fine.
Okay, all right.
Okay.
Did everybody else get the 31,097.47?
Yes.
Yes. And so how much did we put in? What's the total of our payments? We're paying $100. NT is 240 times. And so of that, $24,000 is our money. And so the interest that we earn is 31,097.47 minus the 24,000. And so we're earning $7,097.47 interest. I got into a little bit of a discussion with the other section yesterday. Right now, interest rates are extremely low. I was surprised when I was putting together your next project. I was looking at mortgage interest rates, and some places have mortgage interest rates below 3%. And so when interest rates are low, if you're borrowing money like a mortgage, that's a good thing. But because interest rates are low, if you put money in the bank, most accounts are giving you way less than 1% interest, so that the interest that you earn is low. Backtrack a little bit, go back into ancient times when my husband and I bought our first house. Interest rates were very high. Our first mortgage was something like 13%. And in order to get that rate, we had to get a variable rate mortgage. Fixed rate mortgages at that point in time were something crazy like 15% interest. And so while when you borrowed money, the interest was very high and it made the payments much higher, when people who invested money were earning between 7 and 10% interest, so that people who had money to invest, the high interest rates helped them. So this seems a little bit low, but again, it's because interest rates are currently low. Does this process of using this formula, if we know how much money we want to set aside to find out what the value will be in the future, everybody comfortable with that one? Did you want to try one more where we know the future value and we have to figure out our payments before we move on? Or do we need another example, or are we good?
We're good.
Good. Nobody wants another example.
I think one more example would be good.
Okay. So let's say, in how many years do you guys want to make it?
Let's do 5.
In 5 years, we need, how much money do we need?
$10,000.
$10,000. We invest in an account, in an annuity that pays, let's leave it at that 2.5% interest, compound it monthly. How much will our payments be? So as I look at this question, we know what we need in the future. We know our rate. We know that we're doing this monthly for 5 years. So n times t, that means we'll be doing it 60 times. And we're looking for the payments. And because we're looking for the payments, I'm going to go to my formula sheet and pull out the formula that's out for P. Gives me P equals parentheses R over N, close, over parentheses, 1 plus R over N, close, to the NT minus 1, close. When we substitute in, actually, you know what, at this point in time, I'm going to shut up and ask you folks to do the substituting, do the typing, and in what, about 3 minutes, I'll go over with you.
I got a 156.64 cents.
And so because we round up, let's round it to the nearest dollar. 157.
So usually if you like round up, you have to look at the third number.
But with these, we're always going to round up. So to the nearest penny, it would be 157.65. To the nearest, I'm sorry, it would be 156.65. I apologize. To the nearest dollar, it would be 157. With these, you're always going to round up. You're not going to use your regular rounding rules. You're just going to round up.
Oh, all right. Okay.
Okay. Is everybody all right with this expression, substituting in?
I think so.
To go from here to here, it's a matter of typing into your calculator. And so again, I told you, I think repeatedly, that with these problems in this chapter, I want to see what you substitute in. I want to see the formula you used. I want to see how you substitute it into the formula. And especially because we're going to be using MyLabs. MyLabs, if this number is wrong, even if you just round it wrong, you would not get any credit. But if I look at your work, assuming I weight everything as if it's a 10-point question, identifying your variables, picking the right formula, substituting in, I promise getting that much will give you 9 out of 10 points. In MyLabs, each question is worth 1. In my mind, this is 0.1 and everything else is 0.9 in terms of the way I give partial credit. And so even if you're having calculator issues typing in, if you can show me this work and get to this point, you will have almost full credit. All right? And so while we're on a roll, did anybody get anything different?
No, I got the 156. I just forgot to round.
Yeah. And again, MyLabs, if you don't round right, they're going to, not give you credit, but I promise I will. And then for the total payments, again, if MyLabs asks you for that, if this answer was off, this answer will be off. But if you show me your work and you show me that you took your answer there and multiplied it by NT, I will give you full credit, because if this answer is wrong, the rest of the problem will be wrong. But if you do the right work with the wrong answers, I'm not going to penalize you twice. So of that money, we're putting in $9,420. And so the interest that we're getting would be the $10,000 minus that, which is $580 interest. I know the formula looks scary, but the process of picking the right formula, copying it down, identifying everything that we know, putting those numbers into the formula. Is everybody comfortable with that much?
I actually do have a question.
Sure, Debbie.
So if it was like 15 months instead of like the 5 years we did, would it be 15, or would we have to do, like, would that be our T?
Okay, let's, I'm going to do this in a different color so nobody thinks that it's what the answer should have been for this one. If, hypothetical, if instead of 5 years, we had 15 months. Remember, the time has to be years. So this would be 15/12 of a year. And so when I multiply NT, I apologize, NT would have just been the 15.
Okay, so we would put it over 12.
Right.
Okay,
Remember that if your time is in months, to change months into years, you always have to divide it by 12.
okay. I was just, okay. Thank you. That clears it up in my head.
Okay. Anybody else have a question? And so if we're saving for something big in the future, we can set aside a lot of money now in a compound formula, or we can make regular installments into a savings account to get that money. The same type of thing occurs if we have to borrow money. And so on the other side of things, if I borrow, a lot of times we pay into installment or fixed payment loans. With an installment or fixed payment loans, examples might be something like a car loan. Does anybody have a car loan where you have to pay the same amount every month?
Yep.
It's a classic example. I don't think you guys have to start paying until you're done with school, but student loans usually work the same way. Sometimes if you purchase something from a store, not necessarily with a credit card, if you purchase something large, I think like if you purchase furniture or something like that, they let you, make a fixed payment type of loan. And probably one of the biggest investments that anybody makes in their life, that's a fixed payment loan, is a mortgage. And with these, when we talked about that annuity, we said every time we make a payment, the interest is only on the money that's in there already. With these, to come up with a formula kind of like blows your mind a little bit, because you're paying down what you owe a little bit every month. And so after every payment, the principal of the loan decreases and it gets refigured. And so to come up with a formula in order to do that, it gets somewhat involved. And we get this formula that's the payment amount. And with this formula, we're only going to look at it from one end, is P, which is the principal, or the original loan amount, what you borrowed in the first place, times R over N. And just like before, R will be our rate as a decimal. N will be the number of compounds in a year. T will be the time in years. We're going to find it easier if we multiply before we begin. And PMT is the amount of each payment. And so payment is equal to P times R over N. And then we're going to have that over parentheses, 1 minus parentheses, 1 plus R over N, close parentheses. Now this next part looks unusual. This exponent is negative. We're raising it to the negative NT power and closing the parentheses. So that's the formula. Does everybody have that down?
I got it.
The first example, I'd actually like to use this formula twice. Let's say we're going to take a $15,000 car loan. Yeah, my husband and I over the summer bought a car, and we sat down at the gentleman's desk, and he laid out all sorts of crazy options for us. Let's say with this car loan, we have two options. One option is a 4-year loan at 8% interest. And the other option is a 5-year loan at 10%. And with car loans, we're always going to, usually you assume you're making monthly payments. And what I'd like to figure out is which is the better loan. To find that for each, I'd like to find the payment, the total of the payments, and the total of the interest. So in the middle, I'm going to place this formula. The payment is equal to the loan amount times R over N over parentheses 1 minus parentheses 1 plus R over N, again to the negative NT, close parentheses. And we're going to do this twice, once for the 4-year 8% and once for the 5-year 10%. So everybody all right if I scroll up a little bit? For each P, the loan amounts are $15,000. For this one, my rate, 8%, is 0.08. We said we're doing it monthly, so N will be 12. And this time T is 4 years. So if I look at NT, 12 times 4 would be 48. And so sometimes, rather than saying a 4-year loan, they might say a 48-month loan, or they might say 48 payments. So to find the amount of payments, P is 15,000 times parentheses R is 0.08 over N is 12, close parentheses, over, open parentheses, 1 minus open parentheses, 1 plus 0.08 over 12, close parentheses, to the negative 48, close. And now, if I can remember where I put my calculator, I'll type it in. 15,000 times parentheses 0.08 divided by 12, close parentheses, divided by, open parentheses, 1 minus, open parentheses, 1 plus 0.08 divided by 12, close parentheses, carry it up. And now be careful when you use this negative exponent on your calculator. There should be, don't use the subtraction on your calculator. There should be a button, which is, negative sign in parentheses. We need that for the negative number, for the negative exponent. 48, close parentheses, equals. And so I would get payments to be 366.193. And again, with these, we're always going to round up. So that'll be 366.20. Did everybody get that?
Yes.
So now let's find the other side. Other side, we're still taking that $15,000 loan. This time our rate is, what did we say, 10%? So that's 0.10. We're making monthly payments, but this time we're doing it for 5 years. So NT, that's 5 times 12 or 60 months. We'll be making 60 payments. So interest is higher, but we're making more payments. So what's that difference going to look like? If I take the 15,000 times R is 0.10 over N is 12 over parentheses 1 minus parentheses 1 plus 0.10 over 12, close to the negative 60th. And so when we type this one in, is anybody else getting 318.7056? So we'd say $318.71. Huh. Are we getting this or no?
Yes.
So I'm sitting at the car dealer's desk and he's asking me, do I want to make payments of $366 or do I want to make payments of $318? And wow, I'd rather keep that extra $50 a month, right? So a lot of people just opt for the lower payment. But let's look at the big picture. That's the payment amount. Let's find the total of the payments. So that's the payment times again NT. Or here in the first loan, we're paying the $366.20 48 times. And so altogether, for this car, we're paying $17,577.60. And so how much is the interest? Well, we're paying $17,577.60, but we really only borrowed $15,000. And so that means we're paying $2,577.60 interest. More than the cost of the car. Wow. I'm paying an extra $2,500 for the car beyond its price in interest. Let's look at this other loan. For this other loan, the total of the payments is going to be that $318.71 times, this time we're making NT 60 payments. And so when I multiply that out, this time I'm paying a total of, whoa, $19,122. And so the interest is that $19,122 that I'm paying for the car, minus the $15,000 that it actually cost. And so the interest this time is $4,122. And if I look at the difference in the amount of interest, that's significant. But you got to do what you got to do. If you can't afford the higher dollar amount for the shorter loan, realize that for that luxury of paying a little bit less every month, because it's for a longer time, we're paying a significant amount of interest more. Interesting or no?
I think it's interesting.
Is this something that you guys have seen before? The idea that I know a lot of people immediately look at this and say, well, why wouldn't I go for the lower payment? And usually the sales guy in the car loan office doesn't sit down and spell out for you the big picture, the total cost. And so that over time, even though you have the lower payments, you're paying much more. So now this is mom talking to you, not, somebody working for Mr. Blitzer's book. I know when my daughter got her first car loan, she ended up having to go for the lower payments for a 60-month loan. She was still in school at the time. By the time she got out of school and got her first job, she was making significantly more. And so while her payments were supposed to be this amount, she always sent in extra money. If she could, she sent in an extra $100. So instead of paying the $318 every month, she paid the $418 every month. And what's interesting is if you do that, what the $318 goes towards the interest and the extra $100 goes towards the principal. And what happens is you pay off the loan much quicker. And so she paid off her 5-year loan in 3 years instead of 5. And by doing it that way, her total interest was much less. And so realize that if you have to take that higher loan amount, the longer time period, which over the scope of time has you paying a lot more money, if you eventually can pay more and do pay more, it's well worth your effort. If you get a raise, $100 a pay period or something, put that extra $100 towards your loan, because in the long run, it can save you big picture thousands of dollars in interest. Does that make sense?
Yes.
The only time that doesn't work is if there's a penalty for paying off early. And I don't think there are many loans out there that have that prepayment type of penalty. Most cases, they like it better if you pay it off early. So, should we try? Oh, wait, you know what? And as I'm looking at this, in my labs, in this assignment, on the cost of cars, they also look at another type of problem. And so I'm going to just pull up the homework real quickly. I apologize. I pulled up the annuity homework. I pulled up the wrong one. Let me try that again. Oh, wait a minute. I think it was the wrong one. No, that is the annuity homework. I apologize. Then let me look at the next one. In terms of looking at car ownership, in addition to that cost of payment, they look at the operating costs. And so this says, suppose that a certain car has the following average operating and ownership costs. So that the operating cost is 26 cents a mile. The ownership cost is 68 cents a mile. So the total cost is 94 cents a mile. If you drive 30,000 miles per year, what's the total annual expenses for this car? And so, does it make sense with a question like this to say that if it's costing me 94 cents per mile, and I'm driving, what did he say, 30,000 miles, then I would multiply to get the total cost of ownership. And so that over a year, that would be an extra $28,200. And that cost of ownership, it would include not just things like car payments, but things like insurance, gas, oil changes, wear and tear, maintenance type things. And so it's, another thing that you need to consider with car ownership problems. What's neat is the second half of this question says, if the total annual expense of car is deposited at the end of each year into an IRA, paying 8.5% compounded yearly, how much will be saved at the end of 7 years? And so here they're asking you to use this formula, use this as P, and then use the, they said yearly, so N would be once. You're doing it for 7 years at a rate of 8.5%. It's interesting to see how much money you would save if you didn't put it, earn, if you didn't put that in the car. So, but is everybody all right with this top part, figuring out that car ownership per mile?
Yeah.
Okay. Then last section, and now I'm thinking this might have been what I thought was in homework 8.7. Yeah, homework 26, 8.7. Which was the one that was off? Now I'm befuddled. The one that was out of sync. There was a homework 27, right?
Yeah.
Yeah, that's the one that we're skipping. I apologize. That last homework 26, 8.7 deals with mortgage payments. And so mortgage payments are, again, those fixed loan payments. And so we're going to use that same formula for the payment, that the payment is equal to the amount of the loan times R over N, to parentheses, parentheses, 1 minus parentheses 1 plus R over N goes to the negative NT close. But with home ownership, there are other costs involved with that purchase. So let's say, for example, we want to purchase a home for $100,000. And I think in Western New York, you can still get a reasonable home for $100,000. In other parts of the country, not so much so. I think I just saw something on the news recently that the average home price, the median home price in California is $700,000. To live out there, the cost of living is excessive. Where my daughter lives in the Hudson Valley, there's no houses for $100,000. You have to look at like $200,000, $300,000 in order to purchase a home. But when you purchase a home, something large like that, even sometimes with something like a car loan, they have you make a down payment. And the down payment is usually a percent of the purchase price. It's money that you pay for the home. It goes to the seller. I could tell you stories about down payments. Usually you have to sign off on that down payment, before they stop showing the houses to other people. That down payment is money that you pay upfront at the beginning of the process. And it's money saying that you're good for it. You have the financial responsibility to pay for a house, purchase a house. It also says that you're really interested in this house. If you back away, you don't get your down payment back. So that it's money that you have to really be serious before you put it in. Let's say in our example, you have to put 20% down. Oh, I just remembered the other thing that I wanted to say. Everybody remembers maybe in like 2008 when the economy crashed and they blamed it on bad home loans. And it was bad home loans because mortgages had always been a real secure investment for banks. And so they wanted more and more mortgages. So they started not checking people's finances and not making people do down payments. And all of a sudden people were taking mortgages that they couldn't afford. And that was kind of the beginning of the end there. But I digress. So let's say we make a 20% down payment. The amount of the payment would be 20% of the price. And so again, like we said at the beginning of this unit, that means we're going to take 0.20 and multiply it by our purchase price, which will give me $20,000. And so that means if I'm really going to buy this house, I need to have $20,000 cash up front. But when we go and figure out the mortgage amount, it's going to be the purchase price minus, let me not use the letter P. The price minus the money down. And so on this $100,000 house, where I'm paying $20,000 up front, I'm only going to need a loan for $80,000. And so that would be my P in the formula. And I'm looking at the clock and I'm thinking, we're going to stop here and we'll pick up with this situation next class. I'll cut and paste this problem into next class's notes. So let me close that. Let me stop sharing. Let me stop